We say that it is precisely because of the decoupling between the allocation result and the pricing result of a second price sealed envelope auction for a single item that leads us to this desirable property of truthful bidding being a dominant strategy for each bidder. That is, you should bid your valuation no matter what the other bidders might be doing. So how do we understand this somewhat counterintuitive result? We look at this from three different angles. The first one is just to look back to the more intuitive open auction. Most of us would agree that increasing price in open auction is very intuitive. But if you think about the price that you get to pay as the winner of an increasing price open auction, your own bid determines how long you stay in the price war, but when it stops, when you pay the price, you effectively pay the bid of the next highest bidder, plus a small amount capped by the minimum increment per bid, unless you overbid much more than the minimum increment. So effectively, you're actually paying the second price. Now, the second angle we look at this is mathematical argument. Suppose, as an advisor to you, I suggest you don't bid your valuation. Well, then, Cap, I can only tell you two things. One is, please bid below your valuation, or please bid above your valuation. Let's take a look at these two cases one by one. In this case, suppose I suggest you bid, say, B2D, okay? Not the original B, which is the same as valuation. So now, B2D is less than B. Now, for such a change in your behavior to make any difference, either in the allocation or the pricing of the auction, it must be such that there is another bidder, the second highest bidder, who bid less than B but more than B2D. Okay, in other words, you're taking my advice into account, and lowering the bid from B to B2D would only make a difference in the actual outcome of the auction only if there is a B2 in between B and B2D. Now let's see what happens then, before and after taking my advice. Now after you take my advice, you actually lose the auction, so your payoff is 0. But you could have, before taking advice, you could have bid B equal B, and then what kind of payoff would you get? You're going to get B minus P, of course. In this case, P would be the second price, B minus B2, which equals B minus B2, because you were bidding the same as your valuation. And we know B is bigger than B2, so this is a positive number. So you could have got a positive number, now you got 0. So you say, nope, I'd rather not take your advice and lower my bid below my valuation. What about the other case? Suppose I suggest, hey, don't listen to this advice of lowering. Actually, take my new advice of increasing the bid. Okay? When you increase the bid above the valuation, then what would happen? Well, let's look at before and after again. Again, in this case, by changing your bidding behavior, taking my advice into account, okay, going from B to B2D, it will only make a difference if there is some other bid, B2, in between. Now, in this case, the chain of inequality errors reverses the direction. And in that case, what would happen? Well, before you got my advice, you would bid here, and the other bidder would have outbid you, and you have got 0 utility. Now you listen to my advice and raise your bid from B to B2D, and what would you get for your payoff? B minus P, which is B minus B2, that's the price you pay now, which equals B minus B2. But B minus B2 is negative. So in other words, before this advice is taken into account, you get 0. After, you get less than 0, and that is worse. And therefore, you would also say, nope, I won't take your advice to raise the bid either. So the key point in this mathematical argument is that in both cases, this switch in behavior would only make a difference in the outcome of the auction if there is another bidder in between these two values. And we have demonstrated that you would rather not take my advice to either lower or to increase your bid. And therefore, the only logical conclusion is you should bid exactly same as the valuation.
Still, this sounds like a mystery to me. It's like a cloud there. I don't know intuitively what's the right way to think about this. For example, why not the third price? Okay, sealed envelope third price auction, you charge the winner based on not the one below it, but the second one below it. Okay, what's so special about the second price? Actually, what's so special about the second price is that it depicts the lost valuation to others in the system. So if you were not in this auction system as one of the potential buyer, then what's the second highest bidder now would have been the highest bidder, and she would have gotten this item and received a valuation, a certain valuation. So, but now you jump into the system and she becomes the second highest bidder and you got the item. So the damage that you cause to the system is basically the price that this person is willing to pay for. And that's the third and intuitive explanation of why second rather than third, fourth, fifth price. Now, what about the other folks in the system? Well, even if you were not there, they wouldn't be able to get this item anyway. So they do not matter as far as calculating damage is concerned. Your damage is all inflicted on what becomes now the second highest bidder. So this echoes a recurring theme that there's something called a negative externality. Last lecture note, we talked about the negative externality of interference in a wireless cellular network. And the way to modify that, or what we call internalize the negative externality, is by power control. In this case, the negative externality is the lost valuation to other folks in the system. And the way to internalize that is to charge you accordingly. Now, internalizing negative externality sounds like abnormal English. So a more commonly understandable term would be simply pay for what you damaged. That's how we charge. Well, let's take a look at an example now of second price. Sealed envelope. It's not entirely sealed envelope, actually. We'll see the difference. And the example is around eBay. Now, founded in 1995, I think, with over 40 million users today, eBay, at least in the United States, is the largest auction-based online store. And it sells all kinds of stuff. And some of you may have used the eBay or similar versions of it grown out of your native country. It's effectively a second price auction, except there are four important twists. The first twist is that there's also a reserve price, which is optional. You don't have to set it, and is not released to the public. So you can have a start price of, say, $10 for this Elvis Presley autographed CD. And say, wow, that's a great deal. But you may have an actual reserve price, which is $1 million. Okay, unless the final price is above $1 million, you reserve the right to just cancel the auction and not sell it. Okay. And this is useful because you can make a price very low to attract eyeball attentions and traffic and bidding, and then you still can reserve the right to cancel the auction if it's a very disappointing sales. The second important difference is that there's some information that is displayed. Okay, what is the information displayed? What would happen is that each time that there's a new price, eBay would update an ask price or the announce price. And this price is the following. So suppose the auction concludes right now at this moment. Okay, so what would the price that the winner need to pay? It's going to be the current highest bid or the second highest bid, B2, plus some basic increment delta. What is delta? Delta is basically says you can't pick an arbitrarily small kind of increment each time. You'll make the auction very inefficient. Let's pick, say, the delta is, say, $1 or something. Each time you bid, have to bid at least $1 more than the current one. So the second price is basically the driving force, but with an increment minimum. But in case this second price, once with a little increment, is higher than the highest bid, then you would simply pick the highest bid. So this whole operation is all just complicated because there's a minimum increment. So had the auction concluded right at this moment, you'll be paying the smaller of the two numbers, your own highest bid or the second highest bid plus the increment. But the auction has not stopped yet. So in order to go further, you need to at least bid one more delta above this number. So the announced ask price is this formula. The min of these two numbers plus another delta. Now say then this is not a private valuation anymore because you have some glimpse of what other bidders are thinking about. And that's what makes things a little bit more fun. Okay. The third important twist is there is also a fixed and publicly announced time horizon, usually 5 days, 7 days, 9, 11 days, and so on. This means that everybody knows when this auction will end, and therefore a lot of people wait until the very end in what's called a sniper action. So you may observe that a lot of times you think it's yours until the last 5 minutes or 2 minutes, and suddenly a lot of people jump in with very high bid, and you can't even react to that in time because people know it's the final few minutes that matters in eBay auctions. But there's also another behavior, which is where some bidder comes in with a ridiculously high price and just scare away all the potential competitors off the bat. The last twist is that in order to make this user interface more friendly, eBay allows a proxy agent. That means you can enter a maximum bid you can ever tolerate and say, well, I don't want to sit in front of a computer screen all the time. Why don't you do the bidding for me? You meaning this is a computer proxy agent. So anytime if the ask price is below my maximum tolerance, just go ahead and enter a bid for me. But if it's above it, then just give up. Okay, so anytime when I'm not the highest bidder, but I can still take the displayed ask price, then go bid for me. Otherwise, you stop. So those are the 4 key differences between eBay and second price. So let's take a quick look at a simple made-up example of an auction. So there's one seller who's trying to sell something like a lamp on eBay, and day 0, that's the initialization. You set up the auction on eBay. It's the seller. You say put the 5 days into the duration field. Everybody knows you will conclude 5 days. Ask price would be, let's say, $5, and the minimum increment, that's the delta, let's say is $1. Okay, just to make our example simpler to write down. And you say the reserve price is just the same as start price, which means basically you give up the right to cancel the auction if the sales is disappointing. You just want to sell it for whatever it might be. All right, so now let's take a look at what would happen in the next 5 days. So day 1, let's say one potential buyer comes in, Alice, and Alice uses a proxy agent and says, well, my tolerance is $12. Then what would happen? Well, eBay's proxy agent will therefore say, good, current minimum price is still just starting is $5. That's less than 12, so I will enter a bid for you. I will bid $5. And now the ask price will be therefore 5 plus delta, the minimum increment, which is $6. So in summary, the highest bid at the end of day 1 is $5 from Alice, and the ask price is $6 displayed for everyone to see. Now day 2, Bob's comes in. They say, oh, I'm willing to take that 6. In fact, I'm going to just make it $8. Maybe I'll just get the item. Okay. Now then what would happen? Alice agent would say, well, I can actually take this, because once Bob bids $8, eBay will say, I announce 8 plus delta, which is $9. Anyone? And Alice agent says, 9 is not too bad. I can go up to 12. So I would take that. So I would take 9. Okay, so now the ask price becomes the following. Is the minimum of the highest bid now 9, and the second highest bid 8 plus the delta, which is 1. So they are the same. That's 9 plus 1 more delta. Okay, so that's the 10. So $10 is now the displayed ask price for everyone to see. So at the end of day 2, nothing further happens. Highest bid is now $9 from still Alice, and the ask price displayed is $10. Moving on to day 3. Now Bob says, what? $10? All right, I'm going to, so clearly my $8 didn't work, so I'm going to pay 10 and half. Okay, remember, the minimum delta increment is already included in the display price, so Bob can pay exactly that 10 or something a little higher than 10. Doesn't have to be as big as another delta. It's already incorporated. So now eBay says, good, I'm going to display 10 and a half plus the delta now. That's 11 and a half. Anyone? And of course Alice agent says 11 and a half. That's getting close, but still less than 12. Yes, I will go on to bid 11 and a half. Now the ask price becomes 11 and a half, or 10 and a half plus 1, whichever the minimum of the two, or plus another 1. That's 12 and a half. That's the display price. So at the end of day 3, the highest bid is 11 and a half from Alice, and ask price is 12 and a half for everyone to see. I'm moving on to day 4 now, and Bob say, what's going on here? I'm going to bid a real big number, say 17 and a half. Okay, so maybe I'll get it this time. Now the ask price, what is it? It would be the min of two numbers, the highest bid 17 and a half, or the second highest bid 11 and a half plus $1 plus another increment. That would be 12 and a half plus another 1, that would be 13 and a half dollars. Now Alice agent says, I want to go in, but I was only authorized to go up to 12, 13 and a half. I can't take it, so no action, nothing. And therefore at the end of day 4, the highest bid is now 17 and a half. Finally, it's from Bob, and the ask price is 13 and a half. Notice the ask price is actually not telling you all the information. You don't know what's the highest bid. Day 5, the last day. So happens the third bidder comes in at the last moment. It's a sniper. And so happens he looked at 13 and a half, but somehow guessed a pretty good number, 18, to enter the auction. And now the ask price becomes 18 or 17 and a half plus 1. This is the highest bid, second highest bid plus the delta, whichever is the smallest, plus another delta, and that is 19, because 18 is the smallest of the two plus 1. $19 the display price. So at the end of this day, highest bid is 18 from Chris, who came in at the very last moment, and the displayed price is 19 if anyone want to take it. Well, so it happens that nobody want to take it, and the auction concludes. At the end, who's the winner? Of course, Chris is the winner. He holds the highest bid at that conclusion point. And what's the price he's got to pay? What is the mean of the highest bid and the second highest bid plus the delta? Because the delta set is a little big in this example, so it actually exceeds the highest bid. You would never be asked to pay bigger than your own highest bid, so it will be the smaller of the two, which is 18. So Chris pays $18 and receives the lamp. Congratulations.